Howdy. All right, we're going to talk about one nuance that we haven't seen about Riemann sums and the relation to something called signed area. All right, so remember we had this formula that the Riemann sum was the sum from j equals 1 up to n f of cj delta xj. And remember, these cj's were these sample points, and the delta x's were part of this partition. And we had done this because we were approximating the area under the curve with these rectangles. So the width of this was your delta xj. All right, we always drew the picture with f bigger than or equal to 0, so area under the curve made sense. And in fact, when f is bigger than or equal to 0, then r approximates the area under the graph of f. All right? That was our whole motivation. So we've seen that a lot. Very believable. But what about when f is negative? All right, well then the picture looks just a little bit different, not a lot different. Then f is underneath the graph. And when you do the sum of rectangles here, if this is A and this is B, so this is x naught, and then you've got x1, x2, and so forth. And you've got your c1s in here and c2s and so forth. Use the c to go down to the curve to get the height of your rectangle. So you get this picture. Use the c to go down to the curve to get the height of the rectangle. Remember, Riemann sum was the sum from j equals 1 to n, f of cj delta xj. Here's the delta x1, the delta x2. You see that it still looks like an area, right? As if this is the height and this is the width. But remember here that f is actually negative in this case when f is negative. So really you should think of it as a negative height. And so what you're calculating is approximately the negative area. So in fact what you get is when f is negative, the Riemann sum is approximately negative the area above f. Okay, this part up here, all the area above f. But you get negative times that number, just because all of these values were negative. All right, it's not too hard to believe that in general it's a mix of these. And I'm just going to draw a picture that will illustrate sort of the general case. So if f looks like this graph has this behavior. So that's the graph of f. Here's A, and here's B. And if this is region A1 and this is region A2, then the Riemann sum approximates the area of A1 minus the area of A2. So for mixed functions between positive and negative, you get a mix of the positive area on this part and then minus the area on this part below. And when we take limits, which we will do later on, then this will continue. All right, that's it for signed area. Ciao.